Hello everyone! Welcome again to this tutorial on Python Basics. Under this particular tutorial, what we are going to do is we are going to study about recursive functions in Python. Actually, recursive functions are in almost every language, and there are like scenarios where you can use the recursive functions. First agenda, what is recursion? We are going to talk a little bit about recursion and how it works. And we're going to create a program to compute the factorial of a given number. I'm pretty certain if you have any little mathematical background, you'll know what a factorial is. So let's proceed. I have created a code for the same. But before we go to the factorial session, let's try to create a program which actually is very simple recursion. And that will help us to understand what recursion exactly is. So when we call a function from itself, then it's called recursion. So when a function calls itself, then it's actually the definition of recursion. So far what we did is we actually used the functions we used to call other functions. And that's how it happens all the way. We created the getLinks, we created the getWebData, and we get the displayLinks functions in the previous tutorial and call them one by one in another function. But when a function calls itself, then see what happens. What we have done over here is we have created a function hello and printed hello word in it and called the function in itself. Let's see what happens. Now let's call the function hello. As you can see, first of all, it printed hello, then it resulted into an exceptional error, and the error is a runtime error. Maximum recursion det exceeded. How did it happen? Let's look at the code first. We had a function, and we called that function in itself. So what actually happens is, first of all, hello is called. Then again, printed hello world. Then again, it called itself. Now what happens is, when it called itself, it again printed the hello word, and then called itself again. So it sort of forms an infinite loop which keeps on running. A very important thing, which I may be forward to tell you so far, is when we call functions, the function call addresses are placed on a stack. For those of you who don't know what stack is a sort of data structure in which the first in, last out paradigm works out. So let's say you can imagine a stack data structure like a stack of books placed over each other. So let's say if you put book 1, book 2, book 3, then you have to first of all take book 3, then you will take out book 2, then book 1. So this is a very basic definition of a stack, and that is how function actually works. So let's say first of all, hello is called. Then second hello is called in itself. So when the hello was called, it was placed at the bottom of the stack, which is in the memory of our computer system. Now when the second hello is called, it's placed up on it. Now the third one is again placed on top of the second one, and so on. So this is the way it actually starts filling up the memory, and the stack grows out of range. And actually in the past, what used to happen is once you try to run some sort of code, there used to be a huge system malfunction because there was no sort of check to actually catch such sort of exceptions, which are trying to occupy the last memory section of the computer using the stack area. So what would actually happen is the program would crash, causing a lot of opportunities of exposing vulnerabilities. Anyway, back to the topic. Since we always cannot call functions like this, we need to have a base case which actually halts the function at some time. Otherwise, we will endlessly keep calling the function in itself, causing an infinite loop. So how do we achieve it? How do we create a base case which actually stops the calling infinitely? Let's have a look at it. So we look at our factorial function. What we are doing over here is we are having an integer n. And here we have actually a base case which actually determines if the n is less than 1 or not. If the n is less than 1, it returns the 1 as value. Otherwise, it executes itself again, reducing the and to yet another 1 number, and then it returns a number. So as you can see, what actually happens is, first of all, factorial is executed. Let's say if we give it a value 5, then since it's not actually less than 1, therefore it will go to the else clause and go over here. And before it can go to the next line, what it will do is, it will first of all execute this factorial, which would execute on 5 minus 1, that is 4. Then again, that factorial will work on 3, then 2, then when it will be 1, it will actually return 1, which will be used by the factorial function, which is on the second top on the stack. And that will have a value of 2. So there will be 2, and here will be 1, which will result into multiplication, and that will return as 2. Now this return number is again returned to the third top factorial function on the stack, and so on. Anyway, I think it's pretty self-explanatory. Let's try to execute this code. We get a value as 5 and see what happens. So there it goes actually. The factorial is calculated over here and actually is pretty fast. And that's why recursion is used quite often. Let's give it a little higher value. Okay. So as you keep on increasing the number, the factorial increases exponentially. This is enough on recursion. In case if you have more curiosity about recursion, I would suggest you go online and search for more functions regarding function, or maybe find a case scenario and implement your recursive function. In our next tutorial, what we are exactly going to do is we are going to study about modules and packages, which is yet another interesting and simple concept of Python, which could be really powerful in case if you're working on a big project. So see you in our next tutorial. Thank you. Have a nice day.